to add a, correct. And well. So what if I wanted to add a thing to this, a set bit operation to this? Is that a thing I could do? I'm not gonna actually do it, because I don't feel like we have any more time. Would it be hard to add set bit to this? How would I do it? Because not being able to change the bit's super annoying. Okay, maybe I will do it. Nobody knows. Right?
Mm.
Does that look like perfectly safe, legitimate Rust code that should do the right thing?
Except for self.
Except for self. Oh, self. Oh, you're all concerned about myself. Good call. Thank you for checking. Other than that, which I should have noticed because it wasn't purple, I'll never use code highlighting. Why? Anything cool with this? Everything cool with this? Does this look like the right set of operations done the right way? Yes. Okay. Well, what do we need to do before we run it? What?
Call it.
Yeah, where do I call it? I'm gonna add another test, right?
Mm-hmm.
Always when you add a new thing, test it. Usually give them these long names so that in test outputs it's obvious what thing we're talking about. Yeah? Everybody happy?
Do you have to tell it to use ref with flag?
Multiple do it, as do it. Do I have to tell it to use left with flag? Oh, I see, yes, yes, I do. Thank you. What I usually do here, which is actually, I think, way friendlier,
Pull it outside the test.
there. Now I can use anything from this stuff.
Mm.
Yeah, pull it outside the test and stick it there. Put hashtag test on the outside. think this is all right. Let's see if it's all right so far. Unused import supercolon star. How nice. All right, well, it says we don't need to do any of this. I think that's a change in the module rules. Nope. So why did it think it's not used import? Oh, right.
Do you have arguments?
Only being used when it's a test, right? So we only want to do that when it's when we're testing. What the frick? I don't know. Apparently today's the day when things are bad. Why is that bad?
Do you have arguments in your test?
No. What you're not supposed to do. Okay, never mind. I give up. Let's put it back the way it was. How was it? I don't even remember.
Use ref with flag.
Yeah, but
Colon,
what was the
colon, ref.
qualifier before? I don't remember. That's it. Use ref with flag. Oh, I see. We're in some weird module. All right. Let's put it back the way it was. The module structure is different from what I usually do, so I'm a little confused. Cannot find value PB in this scope. No, that's probably true. It's called PB. Warning variables not need to be mutable. I agree. Okay, okay. So let's make sure that we can set the thing. Now it needs to be mutable, yeah? Is this gonna give me type warnings now? Yep. So that needs to be warning variables not need to be mutable, I agree. Okay, so that's interesting. Everything passes. We should also check that
But it fails.
that the value's still where we left it. That would be a good thing to test. Okay. Now, you should be a little creeped out if this works, honestly. Maybe it's all right. I think it's all right. But notice that PV here is mutable, but V wasn't mutable, right? So what if I wanted to build a set ref as well as a set bool? Oh, interesting. That would be a little weird, right? Because now I'd be able to mutate that thing, right? I'd be able to get at the V. I guess it'd be all right if I was really careful about how I do it. Right? So we can extend this in various ways. You gotta be really careful and watch out for undefined behavior. Let me show you a real quick undefined behavior example, then we'll get on to macros, which I really, really, really want to do quickly. But I feel like I need to show you this one more thing. If we run into the next class, we run into the next class. Just an interesting example. Let's get rid of it. Let's do a little example here with unsafe code here. Thinking. I think I did this ultimately with vex. And the reason I'm going to use a vector here is because vector is not a copy type, and I don't want to get confused by copy types for the next 20 minutes, so let's go there. I want to sort of play around with what we can do with this. Actually, I don't even want that. I just want to get a reference. Pointer to V equals and sub V0 as pointer mute U32. Everybody agree that I'm okay so far? Yeah? All happy? I got a pointer and I turned it into a reference, which is a perfectly legitimate operation. I've done nothing unsafe yet, but I've got a pointer to the first element of B, which is the only element of B. And I can change that. I can say, let's first just make sure that everything's cool so far. It's always a good place to start. Yeah? All right, we're going to make sure that these things are the same. Oh, sorry, P sub 0 here. Right? We're going to make sure that everything's the same, that the PV is pointing to our storage. Yeah? And look, they both are 0. Yeah? But I can, since this is a mute pointer, right? I can dereference it. Not obviously. Yeah? Everybody good with that? All right, let's do that. I have to think carefully about where the semicolons go. Unsafe is a block, so it doesn't need a semicolon after. This is a statement, so it needs a semicolon after. And these should both be 1 now, right? I've changed the thing that the pointer is pointing to, just like you would have in C. And there is no undefined behavior here. We're all happy, right? Now, if I try to do something gross, like move V, what happens here? Cool. Neat. Wait a minute. Wait just a minute here. That's interesting. Notionally, what does a move do? Right? I had a vector V, and I move it into the vector W. Should W sub 0 be what now? Oh, I guess it's actually all right. Sorry. Yeah, so far everything's cool. I changed the thing that PV was pointing to 1 and then moved it, right? So actually that should be okay. What if I do it the other way around, though? Sorry, I thought that's what I'd written in the first place. Well, I just moved V, right? Okay. Does this run and produce the same answer? It does! Yeah. Now I should be a little nervous, right? Where does PV point? To where V used to be. But apparently where V used to be is where it is now. True. How fortunate. It turns out that even in debug mode, which is what we're in, the optimizer's like, oh yeah, I don't really need to actually move anything here, right? What would a move look like if there was a move inserted? Copy operation, right? It makes new storage for W, copies all the bits of V into the new storage, and then the storage left in V is what? Undefined, right? Yes, no one knows. It could be marked as unused. It's not even marked as unused. It's just undefined. There's no, that storage is not meaningful anymore. So this program runs fine, and yet it has undefined behavior in it. Because if the compiler ever did decide to actually move v, who knows what that println would print when it got to printing pointer to pv, right? It could play rogue or erase your disk, right? What?
Is it possible to force the compiler to move it?
It's not easy. I played around with that last night a lot and never got to a place that I was happy with. But maybe if I store into v, the right thing will happen. Let's try this. What? Why would it? Yeah, but I'm storing the v. You can store into a location that's been moved out of. That's okay. Right? It temporarily leaves and then I put it back. That is absolutely legit Rust code. So I think I'm all right. And now v and w have to be tracked separately, right? War error argument never used. What was it talking about? Oh, right. I got a third curly bits in there. Oh. So now, instead of our altering v, which is what I was originally pointing at, my pointer right actually altered, what? It altered
W.
w. Because w is where v was apparently. So it doesn't actually do a move, right? It still doesn't do a move, it just allocates new, the storage still gets swizzled a funny way. Anyway, there's a tool for this, for checking for this kind of thing. MIRI is the middle intermediate something interpreter. Why can't I not think of it? Middle intermediate representation interpreter. MIR is the middle intermediate representation of Rust. This is a tool that runs your program under this interpreter that checks for this kind of stuff. Let's see it in action. Nope, doesn't find it. Everybody will tell you, well, I think my code's not full of unsafety because I ran it with MIRI and it passed. All the tests with MIRI and they passed. It's like, no, that doesn't work. MIRI tries. MIRI doesn't catch everything. Let's make MIRI catch our bug just to see what that looks like. It turns out that that's a thing I can do. I'm gonna say this, and then I'm gonna put some curly braces here to scope things. I don't have any of the other things anymore. I don't have any W's. I don't have any of this stuff. This is enough, right? This is already undefined behavior. Somebody explain to me why this is undefined behavior here. What happens to v after the closing inner curly brace?
It's dropped.
It's dropped. It's not only dropped, it leaves lexical scope. It's just gone. There is no v here, right? It's local to that block. And yet here I am dereferencing the pointer to this now gone stuff. Does this actually run if I cut down the number of curly braces?
Won't PV shadow? Like, aren't you gonna have the PV in the curly braces, just not the
Oh, yeah, you're right, I've got a let here, so that's dumb anyway. This is what I meant. This is what I meant, thank you.
You,
Oh, segmentation fault.
Huh.
Now, when I ran a very similar example last night, I got no segmentation fault. That's interesting. Interesting. So why is that? Let me think for a moment. Why is it that yesterday?
PV is uninitialized.
No, PV is absolutely initialized after the end of that block. So that's how this broken.
It's not
Doesn't matter. PV is a mute pointer. I'm pretty sure it'd be pointing at 32.
but
Eh,
it's just,
No, if it were really uninitialized, if the compiler thought it was uninitialized, the compiler would have said, no, PV is not initialized at the point where you're referring to it. Even an unsafe code it would have done that. Let's change this code around like this. I'm surprised this compiled. I sort of don't understand why it does compile. Didn't, I think. Yeah, type annotations needed. It's not sure what's going on. It's like, well, I don't see any PV here, and it would have given me an error later. There. Yeah, use of possibly uninitialized variable PV. So it will tell you if you screwed up. But what this is Rust's funny compound let statement. You can make the declaration and then make the actual initialization later. But if you do that, you have to guarantee that the initialization is made across every path where it's used. And so it actually has a little check for that. And so if I do this, then it's like, yep, sure enough, by the time you get to using PV again, it's there, and it just lets you dereference it. In this case, stories are just gone. Boom. This kind of thing's